this video, we will start Chapter 9 Circles in Class 9 Mathematics CBSE. We'll start with 9.1 Angle subtended by a chord at a point. We will also solve exercise 9.1 questions. The first theorem 9.1 says equal chords of a circle subtend equal angles at the center. So let us take a look at the circle over here. If AB and CD were two chords, we have to prove that these two angles that these chords are subtending at the center are equal. Let us start the proof of this theorem. So we said AB and CD are equal chords, that is they are equal in length, of a circle with the center O over here. Now if I have joined these lines AO and OD and OB and OC, and if I am considering triangle AOB and triangle COD over here, I can say that AB equals to CD because we have considered them as equal chords. Secondly, I know that OA is equal to OD here because it's the radius of the circle. From the center to the edge, both are radius of the circle. I also know that OB equals to OC. Similarly, from the center of the circle, OB and OC will also be equal. So using SSS congruency, I can say that triangle AOB is congruent to triangle COD. So CPCT, I can say that the angles in these two triangles are also equal. So I can say angle AOB and angle COD are equal, hence proving that these two equal chords are actually subtending equal angles at the center. The second theorem is the converse of the first theorem, and it says if the angles subtended by the chords of a circle at the center are equal, then show that the chords are equal. Earlier we knew that the chords were equal and we were proving that the angles were equal. Here we are given that these two angles are equal. Let's prove that the chords are equal. So AB and CD are two chords and angle AOB equals to angle COD, we know that. Now if I consider the triangle AOB and triangle COD, I know that OA and OD are equal because they are the radius, and I also know that OB and OC are also equal because they are also the radius of the circle. Now I can say that AOB and COD are congruent from SAS congruency rule because this is the included angle and these are the two sides. Here from CPCT, I can say that AB and CD are also equal, which means chords subtending equal angles are equal, and we have proved the converse of the first theorem. Let us start solving exercise 9.1 questions. The first question says, recall that two circles are congruent if they have the same radii. Prove that equal chords of congruent circles subtend equal angles at their center. So if we take these two circles, what makes them congruent? If their radius is equal, then it makes them congruent. So now what we have to prove that the angles that these two chords that are equal are subtending equal angles at the center. So we need to prove that this angle and this angle are equal. So let's say AB and CD are these two equal chords in these two congruent circles with centers M and N. Now I know that radius is equal for these two circles. If I take triangle AMB and triangle CND over here, I know that AM and CN are equal. Similarly, BM and DN are also equal because they are radius of the congruent circles. Both the circles have same radius, so they are equal to each other. Now I know that AB and CD are equal because the chords are equal. So using SSS congruency, I can say triangle AMB and triangle CND are congruent to each other. So from CPCT, that is common parts of congruent triangles, I can say that angle AMB and angle CND are also equal to each other, which has proven that equal chords of congruent circles are subtending equal angles at their centers. Second question says, prove that if chords of congruent circles subtend equal angles at their center, then their chords are equal. So this is kind of the converse of the first question that we saw. Here they are already saying they are subtending equal angles at the center. We need to prove that these chords are equal. Let us start with these two circles. Let AB and CD be two chords of these two circles with centers M and N respectively. I know that angle AMB and angle CND are equal. Now considering triangle AMB and triangle CND, I know that AMB equals to CND because that is given to us. I can say that AM and CN and BM and ND are equal because they are the radius of congruent circles. So I can say A and B is congruent to C and D from side angle side congruency, because this is the included angle of these two sides in both the triangles. So I can say A, B and CD are equal from common parts of congruent triangles, or CPCT, from the congruency we have just proven. That is the end of part 9.1 of chapter 9 circles.